We'll start in a few moments. All right, well, this is probably gonna have to wait. I think it's just on the next side because it's 6 minutes in. All right, let me share my screen here. And boom. Okay, so let's go ahead and start this thing off. Now, thank you guys for the ones who did show up. Now, we're actually going to do just a little recap. I know that you guys here kind of already probably went through that on your own, but we are recording, I do want to, go through that for the ones that's going to watch this on the playback, right? So always, I like to start off with going into Notion first. So with recapping, let's go ahead and go to our lesson. What is a network? Now we kind of did as far as the exam topics. Let's look at the exam topics really quick. Let me pull those. Exam topics. Okay. So as far as exam topics, okay. Yesterday we basically went through 1.1 to about 1.3, right? That's what we're gonna say. So let's go ahead. What is a network? Now we have the PDF, we went through it. What is a network? What does it consist of? We also went through the OSI versus the TCP IP models, right? We didn't individually go through 1.1 and all those other, like I have a PowerPoint for them, a PDF, but that's something that you should have went on your own. However, we went through it briefly. Now, since we went over what does a network consist of, and like the OSI model and the TCP IP model, then you would better understand L2 and L3 switches, right? You'll know that L2 switches operate on MAC addressing, right? Because that's what layer 2 is all about, MAC addressing. And then L3 switches is all about IP addressing, because that's what layer 3 is all about, IP addressing, right? So you'll be able to understand the PowerPoints because we went over the components and the layers that the components live on, right? Also went even more here as far as like, routing. What is routing? And it has the 3 elements. It has the protocols, right? Routing has algorithms to determine the path of the travel of that data that you want to send. And routing has databases, right? Forwarding decisions. We will definitely get more into this, but this is something to like, make sure that, the terms are in your head now. But we have a whole section about IP addressing. Continue on, it talks more, like I said, about L2, L3 switches, and talked about next generation firewalls and IPS, right? IPS is intrusion prevention system. It's a defense approach for protecting the network against like, traffic, unwanted traffic. So basically it has different logic than like a firewall. It says, hey, well, actually we can look at this right here. It's basically, it's like almost like a firewall box. It's an ASA. It's like a Cisco router, you can call it. But basically it has this mechanism in it to where if some type of, unwanted activity or data was coming through, it would not only block it, but it would determine what else to do with it. So it has a little more knowledge, logic, a little different logic, you can say, but it all works the same, right? And Ngfw, that's just next generation firewall. That's basically just a step up of security. Basically like, a more in-depth of firewall. Because most firewalls, like, we're going to block, Facebook traffic, we're going to block Instagram traffic or whatever, website traffic you want to block. But with next generation firewalls, you can actually block port numbers and actually you can block the actual URL than just the IP addresses. So if I wanted to block people from accessing Google for whatever reason, I would, on a firewall, regular firewall, I would probably say, hey, no traffic from 8.8.8.8. But with the next generation firewall, I can say block traffic from www.google.com. So I can actually put that fully domain name in there to block it, which traditional firewalls don't have. So again, we'll get into that when we start security section. So, as long as you understand IPS and firewalls and next generation firewalls, we can actually go a little deeper into them. And then access points, right? We talked about wired and wireless access points. It's just a way to access the network. And then controllers, you saw about Cisco DNA and the wireless LAN controller. DNA is a digital network architecture. It's just a software app, it's like logging into a website and it just helps you manage your network instead of actually going into the CLI line like we did yesterday and saying these different types of commands. We could just go into something like a GUI to just click, click, click and say, oh, so this network is down, this network is up, this Wi-Fi strength is probably, these are the end devices that's connected, very easy user face. And then the wireless LAN controller, basically it just allows you, like, look at the diagram right here, allows you to control different wireless controllers, right? So the end users can get on it, right? So if it's just a wireless controller, that's really all it is, which we'll get in. There is a whole wireless section because there are network engineers that are specific to wireless, right? So let's go ahead and get, oops. We have endpoints. We talked about endpoints, right? What is an endpoint? An endpoint is, from the definition, a computing device that communicates back and forth with our network to reach resources such as data storage and other endpoints. Just a fancy way of saying your desktop, your laptop, your whatever can connect to the internet is an endpoint, right? We're just trying to get data storage. We're trying to connect to other endpoints, to other people, to other computers. So that's all that is. Servers, right? We talked about a server, a computer that serves information, pretty self-explanatory. So you have a client and a server. The client, which is you, which is us, which is our computer, is going to say, hey, I want to go to google.com. It's going to send that over, request to the server, and the server is going to say, oh, well, here's google.com, right? Serves information, and then, well, we talked about all of that. Let's just go into 1.2 really quick. 1.2, we talked about architectures and topologies, right? We didn't go too deep into two-tier, or we did a little bit of two-tier and three-tier, but we didn't talk about spine leaf and Soho, small office, home office. Like I said, it's kind of explanatory, right? It's just a small office architect or home office architect on premise or on the cloud. again, this is very high level because we're going to actually get deeper into these topics, but high level, on premise or in the cloud. Either you have the computer, you have the server here that is in physical form, or it's in the cloud, it's virtualized. You are using it from a third party, like AWS or Azure, right? Um, 3-tier, like I said, we talked about 3-tier: access layer, distribution layer, core layer. Yes? You might have a question?
No, my bad.
Oh, you good. So yeah, so we talked about 3-tier, the access layer, distribution layer, core layer. So, what happens at the access layer? You just access this layer. Distribution layer is all about filtering, routing the traffic. That's where the firewalls will go as well. Core layer is just about moving traffic as fast as possible, right? It's assuming that all the traffic has already been filtered. Everything is good. We're just trying to move it. So we just went in a little bit more. 2-tier, same as that, it's just collapsed core, what we'll call it instead of 2-tier. Sometimes we call it collapsed core. Smaller network, it's just core distribution is actually done at the same layer instead of separate. And it's lower cost, right, for smaller networks, smaller businesses. Spine leaf, like we said, we didn't get into it too much. We will kind of later on, but just a high overall, it's just 2-layer network topology. It's composed of like spine leaf switches and leaf switches and spine switches. So as you can see right here, we have a leaf and we have the spine. The spine basically is just like the backbone of the data, and the leaf just is like piggybacking off of the spine, right? It's just 2 different ways of having switches in the network. And again, it's for larger networks. Most of the time in a smaller network, you'll probably have like, 3, 4, 5, maybe even up to 10 switches. But in an enterprise environment, you can have up to thousands of switches, right? And they will communicate with each other. And they can communicate with each other in a architect like this, in a topology like this, a spine leaf topology, where we have our core data, which is our router, but our data is being switched, layer 2 switched around in a specific type of way, in a way where we have our main data and then we have our data that's trickling off and piggybacking, right? That's really all you need to know about it. But like I said, I have some things over here where why this spine leaf was created, to overcome limitations of the 3-tier architect, right? It offers a high bandwidth, low latency, and non-blocking server-to-server connection. So again, it's just a better and a different way to move traffic, right? In a larger environment, in an enterprise environment. We talked about WAN, wide area network. It's for larger connections. It connects multiple LANs, right, together. So we will be operating off of a WAN because I'm in my own LAN, my own home office. You're in your LAN, and so and so, so and so. So we are all connected and able to be here and collab with each other via a WAN, a wide area network, right? It's managed by a service provider, like companies like a phone company or a cable company. Like I said, I work for T-Mobile, so we definitely were providers of WANs. So businesses would come to us and say, hey, can you be my internet service provider? Can you provide, a WAN for me that is private, that only I can send data across between my different buildings, right? And that building could be in Georgia, then Texas, then Cali, but we all on our own WAN. No one else can see the data, right? We'll be paying for it. We're paying for that connection. Just like we're paying for their connection now, we're just paying for a LAN instead of a WAN. That's why our bill is probably like $100 a month or $50 a month or something like that, right? And then Soho is small office, home office, exactly what it sounds like. A user who works from home or a small office with a small number of workers and devices. So look at this setup right here. We got like 3 devices. You're either connected with you have wireless connection, which is the Wi-Fi. And you also connect via Ethernet cable, which I'm actually connected via Ethernet cable right now, and it's pretty awesome with my it's pretty good with my speed. I was lagging earlier in the first meeting, and now that I hooked up my Ethernet cable and decided to plug in and hardwire in, my connection is much stable. And that's just something that you would actually do in the field, right? People would say, hey, my internet connection is terrible. Can you help me? And you would be troubleshooting. But I mean, the main troubleshooting, that's why I like to start off at layer 1 is, hey, are you on Wi-Fi? Do you have an Ethernet cable? Can you hardwire into the modem or to the router? Especially if you're at the work office, you should automatically be, connected via Ethernet cable, and most of the time that resolves most of the, quality issues there. So let's go ahead and let's see what else. We have on-premise and cloud. On-premise is exactly what it sounds like, host everything in-house in an on-premise environment. So like I said, you control everything. Or you can have a cloud environment where you have a third party host that thing for you. So you can literally have your computer create a virtual machine and then use that virtual machine, put a server instance on it and use that as a server for whatever you want. Or you can use OneDrive. You can use Microsoft OneDrive to host all your server needs, like your pictures, your files, or whatever you want to store. It's all up to you. Do you want to have it on local or do you want to have it in the cloud? Cloud is less secure than on-premise, but on-premise is much more expensive because not only do you have to buy the equipment, you have to pay for the labor for people to manage that equipment. As far as on the cloud, that already comes in tandem with inclusion with your monthly subscription, right? So it just depends on what you have going on. And, is security top? Security is always top, but sometimes, it depends on what you're doing. And then boom, we just went over that. Let's go to Notion and let's just go over 1.3 here.
Just
Yes.
that's spine leaf. That's new to me. So that's like with the mesh topology, the star topology, and all that. Spine is what, like the top of it? Because they taught us all the other ones. They never brought up no spine.
Right. Spine leaf is something new.
Okay.
Yeah. So it's not something you're gonna really see that much. However, it is basically it's better out there. It's because it offers that high bandwidth, that high redundancy.
I'm about to say it looks better from the chart. It looks like it's actually sending out equal data to every part. Like you only got to spin it to a couple spines, and the spines will send it to all the leaves.
Exactly. That's the whole purpose. But the thing about it is expensive. So a lot of companies are all cost effective, even the big brand companies. So you may see this and you may not. Again, it just depends on their budget and what they deem is necessary, right? But yes, Spine Leaf is exactly what it's there for. Better redundancy, better bandwidth, right? So yeah, let's go into Notion. Then we talked about 1.3. Let's just review that really quick. We talked about cabling types. We talked about, let's see, single mode fiber. We talked about copper. Okay, let's talk about copper cables. Copper cables transmit data through electricity. Fiber cables, or you may hear fiber optic cables, transmit data through light, right? So the data, the ones and zeros, which is decoded into hello, mom, or good morning, or whatever. Through fiber, it's light. Through copper, it's electricity. Okay. With copper, we have the 3 cables: straight through, crossover, and rollover. We kind of talked about that a little yesterday. And then the 2 types of fiber cables is single mode and multi-mode, right? Single mode can go really, really far. Multi-mode cannot go that far. However, it supports multiple modes of transmission, so I can send and receive, right? But it's just a short distance. And then we come down to connections. We had Ethernet shared media and point-to-point. Basically, we talked about the standard 802.3 by the IEEE. It's just governing wired technology, right? When we talk about shared media, which we'll go in a little bit more for today's lesson, is shared media is a collision domain, right? Shared media is what we would call a hub. You may hear about CCNA CD. Now, back in the day, I don't like MySpace days, right? I had a flip phone, and that flip phone could not get on the internet. And actually, I would say a little after MySpace days, probably Facebook days or something, I couldn't get on the internet and talk on the phone at the same time. That means my phone only had CCNA CD capabilities. It was a shared media. I could not transmit both ways. I can only do one thing at a time, had a bunch of collision domains. So that's exactly what that is, exactly what shared media is, exactly what collision domain is. You can only do one thing at a time. Do you want to get on the internet, or do you want to talk? You want to make calls? You want to text? You can't do it all. Now we can do it all. We can literally be on our phone, or even on FaceTime and still surf Facebook or get on Google or whatever the case may be. So shared media is something that you definitely want to pay attention to. If you look at this diagram, these circles represent a shared media. So if this whole one thing is a shared media, it's going to have collision domains. So one person, one computer, one device is only going to be able to share or send data one at a time. As far as these, look, they're on their own collision domains. So they don't have to wait for someone else to go. It's basically in the PDF that I sent, it talks a little bit more about CCNA CD on the OS side, TCP IP model line. I believe it was this one. Yes. I talked a little bit more. It's not, I don't believe it's going to be on the exam. However, it is good to know what it is, because you may get a question that kind of pertains to that. And if you don't even, let's see. No, it's not on this one. So we'll get into it then. That means it's coming up if it's not on this document that we talked about yesterday. But regardless, we'll go more on it. I think that's when we get to switching, when we get to network switching and how we switch data. So moving on. Point to point is just routers and switches. It's just a point to point connection. So when you say, oh, what's a connection? What's a point to point? That's kind of self-explanatory. It's point to another point to another point, right? And concepts of PoE, we didn't really talk about that, but it is in the reading. PoE, it means power over Ethernet. It is just a PoE switch basically means that it will send the max amount of data used to power the power device. So right here, this is a switch. This is a PoE switch. That means that this switch, plug it into an outlet. It will, when you plug, let's see, your VoIP phone or your wireless LAN, let's just say you plug in some network camera. You plug it in, you plug it into the back of the switch. The switch will say, hey, this is a network camera. It probably needs about 8 kilowatts or something. Let me go ahead and send 8 kilowatts to the network camera so it can power up. So now you don't even need to plug the camera into a power outlet. You could just
kind of like a home security system.
Yeah, exactly, in a sense. Correct. So yeah, this is really good for VoIP phones. Like I said, I am a voice network engineer, so we use these PoE switches all the time. If it's not PoE, then we don't need that switch, because it's just better to allow the phone, to get its power from the switch. But then, yeah, go ahead.
Did you say that this PoE switch replaces a power source?
It can for the devices, so for like the network camera, right? So you can assign power to the camera instead of, like I said, using the camera's power source, because the camera will have a power, a power cable that plugs into the outlet.
Right.
So the PoE switch will give it the max amount of power that it needs to power on.
Oh, perfect. Okay.
Yeah. Yep. Now you can't run into an issue, because what if the switch go down? Then everything connected to the switch will go down, right? And that could just be that outlet. Maybe the network camera was plugged into a different outlet, so it wouldn't go off, but the switches did go off because that outlet went out. So you kind of think of ways of like, okay, well, it's all good, but what happens if this outlet go down? So that's just another thing you got to put into your mind when you're architecting, where you're building these networks, because you're in charge of ordering cables. Ordering equipment, ordering switches, and these come $10,000 refurbished. So let's go ahead, go back. What is a network? Okay, so we went over that, and then network basics. I put it on the YouTube channel, which is unlisted, just for us here, not for everyone. Okay, so let's go in. Let's go in here. Oh, and then labs or flashcards. Hopefully you guys did your flashcards, a little learning and labs. It was just packet tracer, downloading packet tracer. The guide, the process is right here. Okay. All right, so let's go in today's lesson. Today we're going to talk more about, let's see, 1.4. We're going to talk more about collisions, duplex feeds and all that. I'm going to go back a little bit into TCP, UDP just to make sure you kind of got that. And IP addressing, that's the big one. Okay, cool. Let me clear this off my screen. All right, so 1.4, collision errors, mismatch, duplex, and RSpeed. Now, really quick, let me just go here. We talked about 1.1. We talked about 1.2. We talked about 1.3. Now we're on 1.4. 1.5 and 6. Perfect. Okay, 1.4. Identify interface and cable issues, collisions, errors, mismatch, duplex, and RSpeed. We will definitely get more into this, okay? This one section, this network fundamental section, which is, the 1 points, it's all about getting you introduced into what we're about to even go further deep into. So yes, some of this may go a little over your head. It's okay right now. It's only day 2. Just know that we're going to just keep talking about this. So moving on. Collision. What is a collision? I just talked about how my speed was so good and now it's just messing up. Oh, you know what? Let me do this really quick. Hold on, guys. I'm going to stop my video. Okay, but you still should see my screen, right? Y'all good? Y'all can still see my screen?
Yeah, we straight.
Oh, okay. Yeah, it's the video because I had the virtual background on. I was doing a lot. So let's just do it like this. So collisions, right? Collision domain. A collision domain is just an area where collisions can happen. That's all that is, right? It's exactly what it sounds like. So this point right here is a collision domain. That means that if this hub is sending information and this switch is sending information and the hub is trying to receive it, a collision may occur. So someone needs to stop, hold, drop, something needs to happen. So a collision domain just means that where collisions can occur, okay? When we talk about duplex, mismatch duplexes. Now a duplex refers to how data flows through an interface, right? So a duplex is saying, hey, this interface right here, can this interface send or receive? Can this interface right here send or receive? Is it going to send or receive, right? You're going to set that. That's what duplex means. Are you going to set this? Well, how is it being transmitted? Is it being transmitted through sending or receiving? So for an example, I will go into this hub right here, and we went into the CLI line yesterday. I didn't even close out nothing yesterday. Look at all of these. Let me close out that. Let me close out that. Right. So really quick, I can go into a switch. Let's just say I'm going into it, and I can actually hold on, you guys, because I have a guide I want you guys to follow with me. Control copy, and I'm going to send it. I'm going to send it in the chat here so you guys can get it and follow along. Cool. So this is a resource I want you guys to use. It talks more about collisions and a little more about the CSMA CD, carrier sense multiple access collision detect. You probably should know what that stands for. I kind of did, but it's okay because I don't think it's on the exam. But again, like I said, you should kind of know what it has going on, right? And it tells you kind of what we're about to get into. So let's go back to packet tracer. So I can go into the switch, and in the switch, we want to enable Again, we'll get in more into the CLI, but we're going to enable us to get into the terminal, and we can do show commands. So let's do show interface. I don't even know what interfaces are. I could do show interfaces, right? So interfaces, let me blow this up for you guys. So if I do show interfaces as a command, and again, we will get more into like the commands and how to work the CLI, but I at least want you guys to have a visual of, duplexes and errors and stuff. So we got interfaces. So at least we got this interface, fast Ethernet 0/1 is up. Line protocol is up. That means that the interface is, it's able to send data, get data, transmit data, however you want to put it, whether it's send or receive, because we haven't got to our duplex. It tells you about the hardware, it tells you the address, right? This is the MAC address, right, of the switch where this interface is connected to, right? It tells you some more stuff. I don't know all this stuff, honestly. But boom, then we have full duplex at 100 megabits per second. Okay, now let's go to our notes. So what do we say duplex is? Duplex is, can this interface send or receive? How does this interface work? So if we have a full duplex, that means that the interface, the port, can send and receive because it's full. That means that you can do both. Half means that you need to choose which one. Auto means that it's automatically going to choose whether it's half or full based on what it's connected to. So if I was to make this full, then since it's connected to this, is this interface automatically going to choose full. Let's go back to our CLI line. So it's full duplex right here. So what does that mean? That means that this fast Ethernet 0/1 can send and receive data. So a lot of times you may have issues with someone saying, oh, I'm not getting, certain data, or my data's slow, or my website keeps timing out, or something in that sort, to where, they're not able to get what they want from the network, the internet per se. This is a place you would check. You would check the interface, and you would probably check, multiple interfaces, or well, not multiple, the interfaces that's connected to wherever, the network has an issue. But full duplex, and it's 100 megabits per second. Again, that's just the speed. So let's get out of there. I don't want to get you guys too confused on all of this, because we will go more when we talk about like QoS and stuff. But anyway, duplex, a mismatched duplex will mess up a user's experience on the network. You'll have complaints, and you'll be like, hey, what's going on? Why is the network not behaving how we want it to behave? The quality is bad. Here's a place you can check. You can check duplex speeds. Speeds come in 10, 100, or 1,000 megabits per second. Okay, those are the only speeds it's going to come in. And then the errors, like I said, you may have people call you or put in tickets, or just something to say, hey, my internet is slow. When I'm trying to, upload my time card, I cannot do it. Or the whole company, or maybe it's they're saying the site in Georgia, every time they try to upload their time cards, the system crashes. Or every time they make, there's rush hour at 5 o'clock and a whole bunch of calls come in the call center, the computer's down or something. I don't know. They just may say something wrong with the network, and you're the engineer, so you're gonna get it in a larger scale than like someone individually saying what's wrong, right? If you're checking the routers and switches, that means that you're checking it for a site. You're checking it for, a whole building, not for one individual person. If one individual person is having an issue, that's their issue. That is not, something you need to check the router for. You need to check their computer, what's going on with them. Now, if a whole group of people is having an issue, then you need to figure out, are they on the same LAN that they're having the issue? If these are the same people on the same network, okay, now let's start checking network equipment. Now we can get to our engineering side. And from my experience, that's rare. That's like probably once a week I'm checking, something that's happening on a site level, on a router or switch level. So that was it, right? That's all to it. Yes.
You dropped that back in the that link back in the chat. I had to switch from my iPad to my computer.
Sure. I got you. Control copy. There you go. Put it in there, and let me see where we at. What do we? And just to pull it up again, that's just something I kind of want you guys to go over. It goes a little more in depth of what we just talked about, right? Collisions, collision rates. It talks more about what we saw on the CLI, how I was telling you, like, you know, the rates and all this other stuff that I just don't really be reading. You can use this command. We just use this command, show interfaces. And then you show interfaces, you can see the interfaces up or down, right? You can see the packets that's coming in, how many total packets we can get. Is it error free? The errors, what's going on with those errors, and a whole bunch of other stuff. And then we scroll down, and then we have our duplex and our speeds, right? Show interface, and then it's X/X, which in our case would be show interface fast Ethernet /0/1. Let me see. Let's take a look. It would be, let's just press enter to clear it all that out, because I get confused when it's so much. So I can do show interface fast Ethernet, FA is what we use. And that was what, 0/1. Okay, boom. And then it'll show you just this interface. I did show interfaces, so it was trying to show me all of them. So had I kick in enter, it probably would have showed me like every single interface. But since I specifically said show interface, this one, fast Ethernet 0/1, and you can type out fast Ethernet, but the shorthand is FA. The shorthand even too is SH for show, INT for interface, and then FA 0/1. So that's the same thing, show interface fast Ethernet 0/1, enter, and you see I get the same information. So we have a lot of shorthands here, or you can just spell out everything. If you spell out everything, then you are prone to more errors, more human errors. So, you know, that's why it's kind of good to shorthand. But yeah, so go over that. That's pretty cool. Let's exit out of that. And then where we at? Did we already talk about wide area networks? Yes. And then we talked about cabling, and we talked about that. And we talked about that. Oh, so we done over with this one. Okay. And then boom. That's really all you need to know about as far as the interface and cabling issues, right? Interfaces, can we send and receive at the same time? What's the speeds? So that's it. Let's move on to 1.5. 1.5 talks about compare TCP UDP. We kind of went over that a little more yesterday, a little more. But just to recap, definitely understand the difference between the OSI model and the TCP IP model. The original one has the physical and the data link layer together as link. We don't really use that. That's the original. Again, we don't really use it like that. We usually use the updated one because we want to separate physical, that ones and zeros, between the data, which is the MAC addressing. We kind of want to make that difference. So that's kind of what we use more. We use more the TCP than the OSI, because the OSI is really for people like in the DevOps, because, you know, they care about how it's presented, like is it encrypted or decrypted? They care about the application. Was it Gmail or is it OneNote or Notion? And they care about the session, you know, like how long should the session last of you using this data, reading this data, or having this data in your possession. But more and more, they are looking for engineers who are both skilled in networking and development. If you can kind of really be a boss at all of these, like, you know, the ones and zeros, MAC addressing, IP addressing, UDP, transport, and you can do some development, then I mean, you gold right there. You saved them 2 positions, so you definitely can negotiate a high rate. Now, TCP, we talked about that, right? We talked about a protocol that is connection oriented, meaning that it needs to establish and maintain a connection to send data. it has to have a three-way handshake. Anytime you hear three-way handshake, anytime you see three-way handshake, think of TCP. When you see TCP, you need to think of three-way handshake. That means that the data needs to be reliable. It needs to get to the source. It may be slow. It may not get there as fast as possible, but it's going to get there. That's what TCP means. Okay. UDP. When you hear UDP, you need to think of connection list. It doesn't matter if it gets there. It just matters that it leaves the vicinity, right? Think of UDP as a broadcast, right? A broadcast doesn't matter if it actually gets to your ears. It don't matter if you actually hear it. It's just saying it out loud. Hopefully you hear it, hopefully you don't. So you wouldn't use UDP to send email messages, right? Because you want it to get to that sender. To that receiver. So you use TCP, right? And then here's just a little chart diagram. So you kind of see TCP and UDP kind of side by side. It's kind of pretty self-explanatory when you go through this. It's kind of like, okay, well, TCP, you actually need a connection, and UDP, you don't. So anything else, do you need a connection, right? So here's a little chart there. And then we talked about well-known port numbers, which is very important because we want to know what port numbers we should have open or what port numbers we should close to do certain things. So we want to telnet or SSHN, of course we want to use TCP. SSH and telnet means that we're going to remote into a device. So if I wanted to remotely access your computer to, let's say, help you download a software or something in that sort, or just to, maybe I can't get in another way, I have to remote in. How we get into servers, how we get into routers and switches, we remote in. This router and the switch is at a data center. Physically, it's at a data center. So if we're not physically plugged in with the Ethernet cable, we have to use SSH or telnet to get in, right? So looking at packet tracing, look at this. This is my computer, right? And this computer is connected to the switch. That means that it's trying to it wants data. Now, let's say that this is me, right? And this is the network. And the network is in, let's say, New York. And this is me in Houston. And I'm trying to troubleshoot the switch. Obviously, I can't plug in because I'm miles and miles away. So how do I get into the switch? I have to use SSH or telnet, which we have something called PuTTY, right? A way that you can do it that's like really old school is you can go into the terminal on your computer, which we call the command prompt, which is something like this, and you can use SSH. I don't remember the commands, honestly. And if you don't remember, then you just simply Google. Let's say SSH. You just Google something like that. Oh, I'm not in my Google. But you can take a look and find some run SSH commands. Well, I like to look at Cisco commands only because sometimes, you have to download PuTTY sometimes. Let's see. I haven't used SSH on this. I usually do use PuTTY. Oh, here's Chrome. I'm trying to figure out why. SSH. Cisco command. Cisco packet tracing. That's even better. Cisco packet tracing. Of course, I have to configure because it's a whole new. So I will have to put an actual IP address, which we will. I want to do that now. Got to name the router. That's kind of arbitrary. We don't actually have to do that. I do have to set up a subnet mask. What else we got? Okay. So with SSH, I have to actually configure it. I'm not going to get y'all down that rabbit hole because we're going to do that in the security, in the security section, we're gonna actually configure all this. I don't want to get you guys confused, but I would end up coming to the CLI line, right? From my computer to get into this, I have to use SSH and Telnet, which is, again, the command line, and it's showing the same thing this is showing, just instead of me plugging in with a console cable, instead of using a console, this is a console cable. Instead of using a console cable, I guess we can go past Ethernet. We can go to console. Instead of using a console cable, because obviously I can't, I'm in Houston and this is in New York, I have to SSH. So hopefully you guys can, you know, kind of understand that a little bit. So yeah, so for me to Telnet or SSH in, obviously TCP, and I have to use these port numbers. I have to put in 22 or use port 23 to gain access. 23 means that it's not secure. 23 means that if I use 23 port number to access the switch, anything that I tell the switch, anything that the switch tells me is open to anybody, for anyone else to read, for anyone else to see. If I use SSH, which is secure shell, port 22, anything I say to the switch, anything the switch says to me is secure. You cannot see that. And then if you wanted to like transfer files from one software to the next or one device to the next, you would use FTP, file transfer protocol, port number 21, right? And that's for the server. There's an FTP for a client that uses 20. So on the CCNA exam, they will ask you, what's the port number for FTP? I definitely got asked that question. You may get asked, what's the port number for SMTP, Simple Mail Trans Protocol? 9 times out of 10 is going to be one of these. That's why I put these up here. Now there are 1,000 port number, well-known port numbers. I believe it's up to 6,000 in total, but at least 1,000 is what they want you to remember. But these right here is what you're actually going to probably get quizzed on. So I would say, you know, make these into a flashcard or something, or however how you want to remember them. If you're taking the exam. If you're not taking the exam, just, you know, make sure that you have these in your notes that you can refer back to it, because they may ask you this on a technical interview. So if you have an interview to be like a system administrator or a network administrator, they may say, okay, well, what's the port number for HTTPS? You know, and it's good to probably have in, you know, your resources to pull up really quick, or just that you remember it. You say, oh, 443 or, you know, 44 something. A lot of times they honestly don't expect you to just know stuff off the top of your head, because again, we have the internet, we have the search engine at our fingertips. But if you can say, you know, well, I do know that it uses TCP because it needs a connection. It's, you know, hypertext transfer protocol. It's secure. I believe it's like 400 something. You can say it like that, and they will be like, oh, okay, at least you know your stuff, even though you didn't actually say the port number, right? It's about being able to speak to it, being able to indirectly answer the question. Okay, so boom, that's what we talked about. Compare TCP, UDP, and port numbers. Now we are on IPv4 addressing. Now here, I had just a little diagram for you guys, whether you had it or not, of the Ethernet cables, the copper Ethernet cables. We have the straight through. You can remember the pins, crossover. They will ask you about this on the exam. So I would suggest you know the connections. So when they say, hey, an Ethernet straight through cable, what's the pin connections? Straight through, you should know that it's 1 and 1, 2 and 2, 3 and 3. From one side to the other side of the cable, they match up, right? With crossover, you should know that they don't match up. On connector A, we have the first wire pinning onto connector B as the third wire, right? You should kind of, and on the exam, again, it's multiple choice. So, or it's drag and drop. So they may have something like this to where it says, all right, match the pins to the other side. You may have to take this wire and match it to one of these. So, you know, for me, visual learning was key, because I couldn't probably relay it, but I definitely knew if I saw it and I could match it, to take 1 and put it to 3, and take 2 to put it to 6. But if I was just like, had to write it out or had to, explain it in my own words, I would have fumbled that. So that's why I like the CCNA, because it's all multiple choice, and it's kind of like, as long as you can just remember it in your head or retain it, then you can definitely just spew it all out on the exam, get the CCNA, and then kind of can be done with the information and learn it as you go on the job, right? And then rollover. Rollover is the same as straight through. However, it is rolled in the middle, so it's the exact opposite. So instead of 1 being 1, is at 8. So straight and rollover, you should kind of know those almost immediately. It's the crossover that you kind of have to learn. And not only do you have to learn the cables, you have to know why you would use these cables, right? You would use straight through for unlike devices. You would use crossover for like devices. A rollover cable is a console cable, so you don't use that just to connect to the console. So know what these cables are and why use them. Why would I use a straight through cable? Because I want to connect let's go here. I want to connect a PC. Straight through cable. We can do fast Ethernet into fast Ethernet 3. So a straight through cable is going to connect two unlike devices, a PC and a switch. They do two different things. And how do we connect these two together to receive information? Through a cable. But what type of cable? An Ethernet copper cable. But what type of Ethernet copper cable? A straight through Ethernet copper cable, right? That's something very important to be able to break that down. That right there, that question right there is like a make or break for an interview. Like, what cable would you use? Whether you're using cables or not, just to say you want to be in a system administrator or a networking department. I mean, why would you choose Ethernet cables? Like, which one would you choose? Like simple things like that. So it's really important to know that. Moving on, IP addressing. So I kind of have, exit that. Okay. So I kind of took my own notes a little better as far as IP addressing. What is an IP address? So an IP address is basically an address that allows users to access the network to share data and communicate. It is an identification of a device on the network. So remember we talked about a MAC address. I said every single device that can connect to the internet has a MAC address, a unique MAC address, not one. There are no two MAC addresses that are alike. Every single one is different. And they're different because it actually is an identifier of your specific computer or device, right? That's specific to that manufacturer. That's a physical address. But your IP address is more of your network address. It says, hey, this is the user on the network. So it's not really your physical location or your physical hardware, is more of your network, your logical network, your logical connection. Okay, so you can think of like your IP address being more like your city and state, and your MAC address is being your home address. So if I live in 123 Main Street, New York, New York, my MAC address would be 123 Main Street. My IP address would be New York, New York. Right, so it's like I have different addresses. And then of course, when you look at the models, the OSI model or the TCP/IP model, you see that MAC addressing is on layer 2, and IP addressing is on layer 3. Okay, so the only way you can connect to the internet is you have to have an IP address. So when we talk about IP address, we talk about IPv4. What does IPv4 stand for? Now, let me just actually pull up my command prompt. So yesterday, remember when we did IP config and we put ipconfig. That means that we're looking for our internet protocol configuration, our internet protocol configurations. So these are our configurations for the internet. IPv4, you see, and we have an IPv6. IPv4 is written like this. Let's talk about IPv4. I stands for internet, P protocol, V is version, 4 means the 4th version. So when you look at IPv6, you can kind of think what that means. That's internet protocol version 6. 5, I don't know where version 5 is at, but we do have a 4 and a 6. 6 is pretty new. 4 is old, but we still use 4. Actually, 6 has been out for some time. 6 probably been out since probably like 2000, 1999, something like that. And basically it was just created so, because we were running out of IPv4 addresses. But let's just go in on that. So IPv4 addresses, there are 3 types of IPv4 addresses that you can send information. We can send information in a unicast way. We can send it in a multicast way or a broadcast way. Okay. I don't have a visual for that. Let me exit out of this. My camera's in the way. Okay, in a broadcast way. So unicast, you kind of can already tell what that is. That is a one-to-one connection. That means that I'm going to send data to you one person, right? So mostly unicast, you can say is a text message, right? I want to send it to one phone, one user. Multicast is exactly what that stands for. Multiple people, multiple IPs at one time. So that means that I'm going to use this to send it to like a group message. So if I was to say, if I was to, pull up my iMessage and put, my mom, my dad, my brother in a message and say, hey, y'all, that means that I am using multicast. And then we have broadcast. Broadcast is one to all. That means that you are sending it to everyone. So you'll probably just blast it out to your whole contacts, or maybe a blast to everybody on your email list, or maybe you're just speaking it all out. Regardless of the case, it's broadcast. It's to everybody. This is very important for you to know because it's definitely on the exam, and it's unicast, multicast, broadcast, right? You definitely need to know what types of ways you can send information. Now, outside of those different types of IP addresses, we have private IPv4 addresses. Now, a private IPv4 address is a non-internet facing address, right? Meaning that it cannot route, send, or receive packets outside of its local network, right? Private IPv4 address cannot communicate outside of its own network. It cannot reach the internet. Let's bring up our command prompt, right? I guess we didn't get into IPv. Okay, we have our private addresses. Let's see, 196 to this. So we have our private IP address range. As you can see, my IP address here is 192.168.1.7.174. That means that I can talk to folks, but I can only talk to folks that are on my network. That's on my Subnet Mask, my network. That's in my home, right? That people are actually connected to the same network as me, the same devices that I am connected to. But I cannot talk to anyone outside of my network, meaning to the internet. That's where my default gateway will come in, which will mask this private IP address because we're running out of it. But no worries, we'll get more into that. So private IP addressing, right? If you have a private IP address, that means that you can only route within the network, within the parameters of the network, no one outside of the network, okay? Now, private IPv4 is important because we're running low on the available addresses for every single device to have one to connect to the internet. So just myself, I have my computer, I have my work computer, I have 2 phones, and then I have a computer in my other room. Those are all devices that need their own IP address to send data, to send from that device. Now think of that's just myself. Now think of if everyone in the whole world had that same thing. That would be trillions, gazillions of IP addresses, which we just don't have enough. So since we don't have enough, what do we have to do? We have to make everyone use private IP addresses, which is, hey, we can recycle these IP addresses right here. We can all use the same one. I can have the same one. That's because we're only talking within our network. We're not talking to the outside world. So therefore we won't, run into having the same IP addressing. So if it's like, hey, you were looking up, grenades on the internet, it's like, no, that's not my IP address. Someone else had the IP address that looked up grenades and trying to kill everyone, so that don't happen, because that's, one of the big things national security do. So that doesn't happen. We use private, and then public, we have our own identifiers, because, we're not always on the internet. Now we'll talk about DHCP, which is Dynamic Host Control Protocol, which divvies out IP addresses for us to use so we can manage them effectively. But we'll get there when we get there. Right now, you just need to know that we have private IP addresses. And that's because there's not enough IP addresses for every single device to have. Now we have something called the Internet Engineering Task Force, right? They're the second police of the internet. We talked about the IEEE, now we're talking about the task force of the internet. They basically implement new internet protocols, and they implemented IPv6. Now, we have IPv6, but we're not fully adapt to it. You're going to see IPv4 still around. It's not going anywhere no time soon. But they came up with this document called RFC, which is ready for comments or something. Read for comments. I don't know. But it's RFC 1918. And it basically just details how IPv4 addresses are allocated. That's important to know, because they are going to ask you on the exam, what's the document that the IETF came up with to regulate IP4 private addresses? It's going to be some type of question like that. And they're going to have multiple choices. And most of them are going to probably say RFC. And they're going to have like 1918. And they're going to have the other ones that you're going to probably have to know. And if you don't know that 1918 deals with private IP4 address, you're going to get an easy question wrong. And we don't want to get easy questions wrong, right? We get them hard questions wrong so we can at least save ourselves. So that Internet Task Force, again, they're just letting you know how all of this thing works, how we recycle IPv4 addresses, right? Our addresses are leased to us. They do not belong to us. So what I use today to get on the internet is not what I'm going to use tomorrow to get on the internet. Now you can buy an IP address and reserve it. Maybe if you're like a business and you're like, hey, I want, technically speaking, to have the IP address one something something whatever, I can do that. I would have to go through all these loops, but we're all going to share IP addresses. Okay, now we will get more when we get into routing. We'll talk about how we actually recycle them, and we recycle them using a protocol called NAT, Network Address Translation. So we take one address, we take our private address, and we mask it on the internet to be a public address, right? I don't want to get too deep into that, on the mechanics on that, because that's a whole lesson, but just know that we can definitely recycle and lease our IP addresses out, and we do that using a protocol called NAT, Network Address Translation. Okay. Now, there's another method called subnetting, which we'll get into. But before we do, I want you guys to please make sure you understand this chart. It is the private address range. So we have classes. Our IP addresses are separated in classes, A, B, C. We do have D, E, and F, but I think that's for like the government and stuff. But you just need to worry about A, B, C for private. A is always going to be a /8, which we'll get into as we subnet. But a /8 is with our subnet mask. So we have our anything that starts with a 10. I don't think I have an IP address that starts with 10. No. It's 192. But any IP address that starts with 10 is a private IP address. Any IP address that begins with 172.16 to 172.31, regardless of what these other numbers are, is a private address. And then in this class C, 192, we have, that's actually, yep, 192.168. Anything that begins with this is a private IP address. I suggest you kind of wrap your head around that a little bit. I kind of gave you a little cheat on the side. So when they're going to ask you, hey, what's the private IP address range? Know that is any IP address. Well, they may not give you the range. They may say, choose which one is a private IP address. So know that anything that begins with 10 is private. So if you see anything that starts with 10 dot, private, right? This one can be a little tricky, class B, 172.16 between 172.31. Right? It's a /12. We'll get into the slashes because we're about to talk about binary in a minute. However, this is a little cheat sheet. So private IP address in the class B range, 172.16 to .31. And then class C is kind of easy. You know, anything that begins with 192.168 is a private IP address. So let's look in mine. Look, what do I have? 192.168. Automatically, I'm using a private IP address right here. Okay, right here, my default gateway it has a private address. And I go to my IP config. We'll talk more about default gateway when we get into routing, but at least you can wrap your head around what IPv4 addresses look like and what the private ones look like. They look like this, at least class C, right? Okay. You can talk more about the Internet Assigned Numbers Authority. You know, there's a lot of departments here in the internet world that kind of manages and regulates what we can and cannot do. So this one, they may or may not be on the exam. Definitely IEEE and the task force will be, but the authority, again, they're just letting you know the classes and how it's allocated. It's allocated as far as like, by your location. Now, your internet service provider, your ISP, which you'll hear a lot, you'll hear ISP, just know that it's just a provider that provides internet service, like Comcast or something. They will actually contact the authority and get the IP addresses for you. So unless you work for like a Comcast or a company that provides internet service to people and companies, then you know, they'll already have IP addresses for you. You don't have to do all that. Oh, let me subnet and all this other crazy stuff. But you may actually land a job with a service provider, and you're gonna have to know this information. You're definitely gonna get paid more. So let's go into knowing deep down, you know, subnetting and how do we get to these classes. Let's actually come over here because. Yeah, make sure you guys got that. I have this downloaded. I'm going to put it in the Notion. All right, cool. So subnetting. Before you actually can understand subnetting, let's just make sure we go over some basics. IPv4 addresses are 32 bits long. What that means is bits are ones and zeros. I like this chart. Let's go here. These are bits. Bits are ones and zeros. So 32 of them make up a IPv4 address. The computer reads it like this, but we read it like 192.0.2.1. But when the computer sends data through those Ethernet cables or fiber optics, they're sending it like this, okay? This is called binary. So these are bits, 32 bits long. Now these bits are divided into 4 sections. So we have this section, see 1, 2, 3, 4. These sections are called octets because they are 4 sections and they have 8 in each section. So like an octagon, so we have octets. So 192, that means that we have 8 places of ones and zeros that make up the number 192. Okay, for here, we have 8 places of ones and zeros that make up the number 0. Right here, we have 8 places that make up the number 2, and it's going to keep going. On whatever number that's our IP address is, we have 8 places of ones and zeros. What's ones and zeros? 1 means on, 0 means off. 1 means I'm going to count this place mark. 0 means I'm not going to count this place mark. So if it's in this octet, I'm going to count this, whatever this value equals, whatever this value equals, and all of these other place values are 0. So these 2 place values equals 192. Look at these place values. They're all 0. So clearly our number is 0. These place values are 0, and then you get a 1 right here, and everything else is off. So clearly this place value must equal 2. Now we'll get into place values. No worries, we're going to start subnetting. So you'll know exactly what these values mean. But just looking at it right here, this is what this means. This is how you decode it. So IP address is in decimal form. Binary is in ones and zeros. Okay, they equal the same thing. It's just written differently. Okay, so what we need to learn is how do we break decimal into binary and binary into decimal. That's before you can even subnet, that's what you have to have, that type of foundational knowledge. So let's go into that. Now, I hope you guys are taking notes, because honestly, you have to write these things down. That's the only way that this is going to retain in your head, especially with this section right here, because we're about to start doing some math. People hate math. They say, hey, I want to get into tech. Is there any math involved? And this is honestly the most math you're ever going to see as an architect, right? As the highest you get, this is the most math. It is a little difficult, but it's the only math. And honestly, it's really add and subtraction. You can do some multiplication. You see some exponents here, but I don't pay attention to these exponents. I'm not good in math. You know, I was good in, I wasn't good in math. I wasn't good in algebra 1, algebra 2, none of that. Geometry, I was good with them triangles, but you know, whatever. So just to let you guys know that, hey, I'm not a mathematician. I'm not good at math. I run away from math, but we do need to learn this. And this type of math can be as simple as adding and subtracting. It may be a little longer. We can definitely add some division and multiplication to make it shorten, but as long as you know how to add and subtract, you're going to be successful. So don't get crazy as we go through this, you know. So we want to learn these place values. We want to learn these octets, and they're in 8 sections. And what does these 8 place values mean? These 8 place values is right here. It has to be in this section. Now you can start, I don't start with 256 because that's not 8, that's 9. 1, 2, 3, 4. Now, yeah, take that, just exit this 256 out. Don't even write that. That's stupid. Why is that there? I don't know. I'm sorry, y'all. So worry about 128, 128 down to 1. Okay, that's the 8 values. That's the 8 sections. So we have, if it's 0, that means that don't count this. If it's 1, that means we count this. So if this right here is in binary, it's in our octet, binary octet, and we want to convert that from binary to a decimal form, to a number form, because it's just one octet. So we're just using one number. What would that one number be? We're not counting 1, we're not counting 2, we're not counting 4. We will count 8, so let's keep 8 in mind. We won't count 16, we won't count 36, won't count 64, we won't count 128. So what does this equal? It equals 8. So that means that for this octet, for this, let me go up here. For this one octet, it will be 8, because that's what it looks like in binary form. Okay. And you have to do this. That's the first part. We just did one octet. We got 3 other octets to break this down to come up with an actual IPv4 address. Okay. So they have like a sample like placement chart that you can use. This helps a lot of people, because when you're subnetting, at least for me, when I'm subnetting, I have to immediately write down this chart. When they say subnet, we'll talk about more into subnetting because right now we're just doing binary conversions. But when we're subnetting, I immediately put down this chart. I start with 128, or sometimes I start with 1. It depends on if my mind is foggy or not. But I'll start with 1 and I'll just double. I'll say 1, 2 was, times 2, 4, double 4, 8, double 8, 16, double 16, 32, double 32, 64, double 64, 128. 128 is where I stop. Whew, that's my 8 place mark. Now I have to do, because it's subnetting, you're doing binary conversions. So now my binary conversions can be a little simpler because I wrote down my chart. So when you take your exam, they will give you like a whiteboard and a dry erase marker. I go in there and I immediately write down 1, 2, 4, 8, 16, 20, just to have it. Now it's probably like five, maybe even 6 questions about subnetting on the CCNA. Now, I took a gamble. I probably got one of those 5 correct. I just wasn't having subnetting. I just figured I knew everything else. I can take a jab on the subnetting and still pass. That's just the confidence. I just was overly confident at that time, and it actually worked out for me. I suggest you learn this the best of your ability. If it don't click immediately, don't beat yourself up. Because in the real world, we have calculators that do this. We don't really subnet, but it's a good knowledge to have because talking in this type of binary talk, it's impressive. So it gives you the dollars, even though you're not actually doing the work, just that you can talk it makes you more marketable, right? So just keep that in mind. Don't stress over this, but don't not pay attention because, it has a lot of math involved. So boom, there you go. That is the place marks. 1, 2, 5, 1, 2, 4, 8, 16, 32, 64, 128. That's the 8 place marks. So now we got the 8 place marks. We know, let me come here because I don't want to get too far in subnetting. So now we can do an example. Let's say our example is 168. Let me see, let me try to do a whiteboard. Maybe I can kind of show you guys. But so far, are you guys understanding this a little bit? Anything confusing? Let me know what y'all think.
I'm just taking it all in and processing it.
I'm trying to unlearn what I was taught because I got notes of the chart that you just showed and all that in my book, and I'm looking at it now, kind of going back to what I was doing, but like you said, it's once you put it down for a little bit, when you try to pick it back up, it's like you got to knock the rust off.
Exactly. You don't use it, you lose it.
Yeah, that's true. Yeah. That's real.
That's why we're doing this every day, sometimes twice a day, just depending on, what you guys got going on, for 6 weeks until we're done. Because all of this, you're going to eat, sleep, and breathe this, and then you're just going to dump it all on the exam. Then once you get the exam, then you can breathe. And then it's okay to kind of lose it a little bit because on the job, they're going to teach you. All you need to know is to be able to finagle your way around this information. So when someone says, hey, something says like, duplex speed, you're not oblivious to it. You kind of know like, oh yeah, you're on the interface. Yeah, we can change that if it's not matching up. You could just say that statement right there and they'll be like, oh, okay, she knows what she's talking about. Even though you probably don't even know the steps. You probably forgot all of what duplex. The fact that you said interfaces and you can change it was like, oh, cool. They may even pull your arm and say, hey, well, what's the syntax? What's the commands that you would do to change the duplex speed? And then you can always be like, maybe show interface, or I would have to Google it. I have a book that I use with a lot of commands, or I have a resource with a lot of commands. I don't really memorize the commands. There's so many out there. You can kind of finagle it to your own advantage, and then you'll be like, oh, okay, you know what she's talking about. Anyway, so let's go here. You guys can see this just good. Maybe. I don't know why this acting like this. Okay, so this is our IP address. Now, what I want you guys to be able to do is break this IP address down in binary form. I want you to be able to take any number between 0 and 255 and break it down into binary form. Why 0 to 255? 255 is the max amount of conversions. It's the max amount of versions we can use between ones and zeros, right? As far as IPv4 is concerned. We can only do 255, possibles. So those are numbers. We can take 168, like we have right here. 168, like I said, the first thing I do is I write down my chart. So I probably start with 1, then I want to double it, then I'm going to double it, double it, double it, oh, double that, and then double that, And this is where my math sucks, because I say, well, I don't really know how to double, right? Because whatever, I don't care. Don't put decimals, that's going to confuse you guys. So let me see if I can space it out. Yeah. I'm going to space these out so it's not like all jumbled together. And I'm trying to show you guys virtually, but I suggest you get a notebook, a pencil so you can erase, or a pen if you like to scribble scrabble, and write this chart down. Memorize this chart. Every time you need to 1, 2, 4, 8, so you should know this chart. Anytime somebody say binary conversions, you should automatically be like, oh, okay. I already know this chart. So write this chart down. That's automatically what I do. Okay, then I do 168. Okay, so how I look at it is, can 128, I start with the biggest number if I have a number. It depends on, you can start anywhere, honestly, because you have to either put a 1 for count or a 0 for do not count. So 168. Well, 128 can't go into 68. So I'm going to put a 1 right here, right? So I'm going to count that. And then under a 64, so if I do 164, 128, let me pull up a calendar. So y'all can, yeah, what was y'all about to say?
I was saying it leaves 40.
It leaves 40. Hold on. Because I want y'all to see how.
So are we putting the max value into the 168? Like, are we doing 128, 168, 64, 168, 32, 168? Or is it like what we put in, we're taking that away to what's left?
Mm-hmm.
Correct. So we're using this. We're doing this first, because this right here is 8 place values for each octet. Each octet is a place, right? We have to use 8 of them. So we're only going to do it 168 right now. So 168, what does that look like in binary? So we know for sure that 128 can go into 68. So we can count 128. So let's do 128, right? But if we count 64, let's say we come over here. Oh, hold on. 164. Let's say we want to put a 1 for that. We can say plus 64. And what does that give us? 92. That's way more than 68. So we can't count 64.
Okay.
We have to put a 0 under this place mark. So we back at 128. Now, can we do 32?
Yeah.
128 plus 32. 160. Up. We got 8 more. So we sure can put a place mark. Hold on. I don't like this whiteboard. I should use my pen. So we can put a 1 under here. So we can count what's 128. Do we count 64? No. Do we count 32? Yeah. So what's 128 and 32? That's 60.
Mm-hmm.
So we need 8 more. We can clearly see that 16 ain't gonna be 8. So we can do 0. But we got 8. So we can definitely do 1. And then obviously we're done counting. So we're gonna do 0 for 4 place, 0 for 2, 0 for 1. So in binary, 168 equals 1 0 1 0 1 0 0 0.
Wow. Okay. Wow. That's crazy.
Did your last instructor didn't teach you that way?
I don't think he tried to make it too technical. He didn't really break it down in layman terms. And I tried to tell him, like, you're telling me off of years of experience. I need you to tell me as if it was your first time learning. He never did that. But that was just that's so simple right there. Like
Listen,
mind blowing.
this took me probably like 2-3 months to learn. I honestly didn't even have this down packed when I took my CCNA because it was just so much. Because no matter what I saw on YouTube or any of that, it is high level. And I'm just like, y'all need to speak to me like a dummy. So I decided to actually just go in and teach myself on some like, okay, this is how I do it. Now, you show somebody else this method, they may say, are you a dummy? But guess what? We got this number.
Right.
So regardless of how I broke it down or not, I broke it down.
Right.
You know, so.
I have a question, Jessica.
Yes.
So, is there only one, like, so for 168, can you come up with another number, or is that the only number that you can come up with?
As far as maybe changing this to 0 and putting this as 1, 2, 3, 4, 5, 6, see, that wouldn't work because no matter how you do it, you know what I'm saying, it's the only way, this is the only possible outcome out of these.
You got to go in that direction from 128 down to 1.
Not even that. These are the only possible combinations. No matter where I put these combinations, it can only be at 832 and 128 to make 168. I can do 1, but then guess what? Now I need 7 more. So then I can put 2, but then, you know what I'm saying? I'm still missing. I can only put it at the 8. Even if I do it this way, if I was to go from 1 to 128, my 1s would still be in the same place mark because that's the only possible combination to come up with 168.
Okay.
And you can do the math. So let's do this.
When I did the math, I came up with 111 for the first 3 numbers.
Okay, when you did the math for, let's do 111 for the first 3 numbers. So that's 128 plus 64 plus 32 equals 224. We're trying to find 168. So 224 is way too big.
So I did I did 164 minus 128. So since I can go in there, I put 1, and that left me with 40. And then I took 40 from 64, and that left me with 24. So I put a 1 for that because it went into it.
Okay, so let's do it. You said 168, and you minused it with 128.
Yep.
And you have 40.
Yep. So we got a 1 for that slot.
Okay, a 1 for the 128. So then what else did you do?
Then with that remaining number 40, I've subtracted that from 64. So I put a 1 there, and that left me with 24.
Okay, so you subtract 64. So
why did I see how she's doing it.
Okay, so why did you subtract 64?
Okay, so because I use those exponential numbers. So I have 2 to the 7th power for 128, 2 to the 6th power for 64, and then 2 to the 5th power for 32. So I'm just doing what the brother said earlier when you was like, yeah, carrying over that number and just subtracting it from the remaining numbers. And if it can fit in it, give it a 1. And if it can't, give it a 0.
Oh, okay.
So that's why I was just curious, because I learned a different way today. And I was just curious, can you come up with a different number? I'm like, how does this work?
Okay, so my understanding is no, you cannot come up with another number, right? Okay. Because this is one way in, one way out. Right. How binary is how it's going to be on a decimal form, which is a single number. How a single number is how it's going to be on a binary. It cannot be variations of it, right? So why I have the place marks here. So let's just do a, hold on. I hate this. Can I do a note? Add a yellow note. I don't know. I need to get my notes. Hold on, let me see really quick. No? Okay, that didn't pull up.
But to say when she does the 128 minus 168 and she left with 40, it's almost like she's flipping it. Like 40 does go into 64, but you got to flip it. 64 can't go into 40. That's how we're putting that line into what's left. And if it's too big, then it's not gonna work. You know what I'm saying?
Exactly. So
Oh, I need to flip it.
Flip it. Yeah, flip the way you're doing it.
Oh, okay. I had it right for the first number, but not for the rest.
Right.
Aha. Thank you.
So you have your place marks. So we can choose any number between 0 and 1 and 255, right? So between any number, let's choose, you could throw any number. Let's do 60, 76. Okay. Now we still want to have our place marks. I always, again, I'm on my elementary math. I like subtracting and addition. So if I don't have my computer, I'm literally writing down, 128 take away 76. So I would start off, you can start off either or. I would start off with the bigger number. Okay, so 128, can it make 76? It cannot. So I have to put a 0 here. So automatically my next number in binary, because I need 8 place marks. I need 1, 2, 3, 4, 5, 6, 7, 8. Actually, let me count. Let me go downward so you can see the visual. Okay, so I need 8 either ones and zeros. So my first one is going to be a 0 because 128 is too big. It can't go to 76. My next one is 64. Now that can go into 76. So I would take 76 and minus, because that's what number we're working on. That's the number we're trying to find in binary. Okay, so we're going to take that number, and we can't minus 128, but we can minus 64. So since we know we can minus 64 and it comes out with 12, let's go ahead and add a 1 because we're going to count 64. Because it's almost to 76. So now we have 12. We can't count 32. So the third, that's a 0. We're not going to count that. 12, we still have 12 lingering. Can't count 16 because 16 is way too big. So we're going to do a 0. But we can count 8. 8 is next. So let's go ahead and take away 8. That's 4. It leaves us with 4. So we can do counting 8. That's the 5th one. The 6th one, it leaves us with 4. We can count that. That's it. 4 minus 4 is 0. Now, let's say we can probably count 2 or 1, but what does 2 and 1 equal? 3. We're still missing 4. Where do we get that extra bit? We can't. So we have to use the 4 place mark. We cannot use nothing else. Nothing else will equal to anything else, right? So we have to do 0 and 0. Okay. So we want to work that backwards. We want to say, what is 0, 1, 0, 0, 1, 1, 0, 0? What does this number mean? And this is binary. Flip it to decimal. Flip it to a number. We're going to use the same chart. This same chart. 128, 64. We're going to use the same thing. Okay. So now that we used it, let's go ahead and put. Oh, that's what it was. It was on my clipboard. So we have our binary. Now we want to flip it to a decimal. So we're going to do the same thing. We count 0. Do we count this? Do we count the first place mark? No, we don't count 128. 1, we're going to count the second place mark. That's 64. So let's go ahead and count it. And we're counting 64. We don't count 32. So we still at 64. What's this right here? We don't count 16. So we still at 64. But we do count 16. And we do count 8. No, we do count 8 and 4. Let me erase this. I don't want to confuse y'all.
I finally got it. Thank you.
No, no problem. So we have 0, 1, 0, 0, 1, 1, 0, 0. So this is equals 76. How does it equal 76? Because you're only counting the ones. You're only counting 64, 8, and 4. That equals 76. You can't count any other numbers that will equal 76, but out of these 8, but 64, 8, and 4. That's kind of how you want to do it when you binary to decimal, decimal to binary. I have an awesome, where's my Google at? We have practice binary. Practice binary. Subnetting practice. There we go. This is a wonderful tool. Okay. Let's see, binaries. Let's see, how to subnet, calculators, questions, binary, simple subnetting. So boom, so it says express 169 in binary. So what you would do is you would use this and you would come here to this site. Let me go ahead and take this down, control copy, put it in the chat. And this link, please use it to help you with subnetting, binary conversions, all of that. So it tells you to express this number in binary, which is going to be almost the same question as it is on the CCNA. Let's say express a number between 0 and 225 in binary. You will put it here and you'll submit. If you'll work it out on your own and you're submitted, and they'll tell you if you're right or wrong. You can show the answer, and the answer is going to tell you right here. And they're actually going to tell you how they solved it. It's great to know, different ways of how to solve this. As far as different explanations. I go say different ways, but different explanations. It's cool if that's how you can understand it. So they have the exponents and stuff. That's how my mentor taught it to me. He taught it to me through exponents and stuff. And that's why it took me 3 months to get it, because I just couldn't. My little brain just wasn't going for it. So I had to come up with my own conversions. And I actually came up with it. I was in a study group when I was going through the Ashton program, and we kind of decided to, decide we was going, subnet. And everyone looked at us like, that is so elementary, but that's how we was able to get the answer. So I don't care how, how you look at me and how I get it, I got the right answer. So, and then hexadecimal, we'll talk about that when we talk about IPv6. Hexadecimal, we talked about a little bit, where you have 0 to 9. And then you have A to F, and A starts with 10 and F ends at 15. And it just gives you more decimal values. So instead of only having 9, 10 combinations, you got 15 combinations. So we'll get into that, so no fret. So definitely use this. Very, very, very good resource. I used it a lot to help, and you can do next. See, this is in hexadecimal. You can skip that. We don't need all that. But you can do 100, right? You probably can't do that. But you can do this. You can express this in decimal. Probably can't do that, so you just do next. Just skip the ones that we didn't talk about. But definitely work on your binary conversions. If you're not comfortable with doing taking these ones and zeros and putting it into a decimal form number, then everything that we do moving forward is going to confuse you as far as subnetting is concerned. So before we actually move forward, I do want you guys to let me know if you are getting this. So if this is confusing to you in any way to where you do not have it, I want you to put like a 1 in the comments, so I know how many people are confused, and if you guys need more resources, or if I need to do a more deep dive, or can we move forward to subnetting? Can we start finding network IDs and broadcast IDs from binary conversions? Okay, so I don't see anything. So that means that y'all know what y'all talking about, and I ain't gonna question it again. Okay, so again, this document, which I will put in the Notion, it just gives you more examples of how to, do binary, which we just broke it down, right? Like I said, 0 is you don't count it. 1 is you do count it. When you see 1s and 0s, it's code. It's just like Morse code. You know how Morse code, like, dee, 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 dee. Each little tap means something. It means an A, it means a B, it means a C. So it's the same thing that's going on here. It's just, we only have 8 place values, and we're only going up to 0 to 255. So it's not like, oh, a million numbers or anything, right? And again, you see how it's just going in. I'm actually going step by step on how I get there. So like I said, stop here, practice, practice, practice. Now y'all said y'all got it. So we're gonna move on. So before we go in, we talked about IPv4. We talked about a little bit of the classes. Just going in on the classes, we have Ethernet communication, 5 classes, A, B, C, D, and E. A through C uses, you know, that's what we use. We use A through C. And it's, again, it's different bit lengths, it's different ones and zeros, depending on what network you're on. So that ones and zeros, your IP address lets us know what network you're on, what type of network you're on. D, class D, we have it down here, class D, that starts with 224. That is all for multicasting. So if I was sending out a broadcast, if I was sending out an email to all of you guys and say, hey, class is going to be Thursday at 9 o'clock, and I send that email via, send that all to your email, then that IP address will be used, will start with either 224 in between 239, because it's sending out, you know, a bunch of users, to a bunch of IPs. And then we have E, class E is for the government. That's what, or reserved for future use, but it's really for the government. The government be using this, this class. So unless you work for the government, unless you have like secret clearance, you probably won't use none of these IP addresses. You probably won't even see it. And if you do see it, you know, that's a good thing about knowing, you know, the network fundamentals, because if you see an IP address that starts in this range, then you kind of know like, this came from a government facility. It came from something government-wide, something futuristic, something that is not really out here that's being used. So if you already know how to read that, then you kind of can go down your own little rabbit hole and see what's happening. So that's kind of what that's got going on. I would suggest you really get familiar with this chart. Definitely know the classes. Like I said, D and E, we don't really talk about that, but you definitely need to know, like class A, that means that it's an IP it's an IP that starts with number 1 to 126. Okay, that's the classes. We're going to go in on subnet mask, but right now I want you guys to really focus on the class. Okay, so if on the exam they may say, choose a class B IP address, IPv4 address, and they're going to have all these different IP addresses, but one is going to start between 128 and 191. If you don't know that that's the range of a class B, then you're probably going to pick a IP address that starts with 10. Clearly that's wrong, because it should be in class A. Again, it's an easy one. You don't want to mess up, because you're just memorizing at this point. So try not to get these questions wrong, because they're just, you know, testing your memory. Okay, as far as classes and IP ranges. When we come to subnet mask and decimal form, as you can see, this 255, that is the possible number. That's the biggest, you know, the network subnet can be. We'll talk more about that as we continue on. However, for each class, you should at least know the subnet mask. Okay, the subnet mask is /8 for class A, /16/24. That means that the first 8 bits, /8 is the first bits. The slash is bits, period. But 8 means the first 8 bits. So what is that? The first 8 bits is always going to be the first octet. Okay, only the first octet. So we're only looking at, when we hear class A, we're only looking at a /8. Therefore, we're only looking at the first 8 octets. That means we're only looking at, well, the first 8 bits. Let me not confuse you guys. We're only looking at the first 8 bits. So that means we're looking at the first octet that consists of 8 bits. Because what is an octet? It consists of 8 bits. We're looking at that first one. That first one says between 1 and 126. And it's just going to keep going from there. Now, that's why I say really make sure you're doing what you need to do with binary conversions. So you can kind of be easier on the eyes when you see /8s and /16s, because then you already have done binary so much to where you know a /8 is the first octet, /16 is the first 2 octets, /24 is the first 3 octets, and then a /32 means that all the octets are filled. But you know what I'm saying, it may confuse you a little bit because you're not, you know, working in binary that much. So definitely do those binary conversions. You can count some of these ones and zeros, and then you'll be like, oh, okay. So now, you know, /8 automatically know what's going on. I mean, it may click to you right now. I don't know. It took me a minute to click. I had to keep going over this information, but this may click for you right now. Okay. So right here, it does tell you a little bit about classless and classful. You know, classful means the IP address can only be in a certain subnet mask. So classful means it can only be a /8, /16, /24. Classless means that the IP address can be in any subnet mask. So my IP address, so this is the IP address, right? 10.2.3.2. It will have a subnet mask, which is a /8. You see my subnet mask right here? It's not in a slash because the computer is giving me an output. So this is how the computer is going to read it to best ability. It's reading it in decimal form.
So would that be /24?
Bingo. I was just going to ask, like, who knows what slash this is? Exactly.
Shoot, my bad, I got excited, girl.
Yes, congratulate yourself. It's exactly /24. It's exactly what you do. So that means that this address is in a network that is a /24. It has a subnet mask. It's part of the /24 network, right? That's what that means. We'll get more into it as we start routing to put certain data into certain networks. That's when it'll kind of come full circle with, you know, subnet masks and default gateways and all that stuff. But right now, you just need to know what the subnet mask will equal to. Equals a /24. Okay. That means that 255, that means that every single one of these, where we at? Every single one of these octets and these bits are turned on. So if I count 1, 2, 4, 8, 16, 32, 64, 128, all of these together equals 255. That's why 255 is the possible number. All of these equal 255. Okay. So that means on. All of these octets are on. So we count all the bits, all the ones, that's 24 ones. So /24. We'll get more into it, like I said, as we continue to work on it. So the biggest question, subnetting question on the CCNA and really anywhere, even on the Net Plus, is find the network ID, broadcast ID, and usable host range. Right? This is the easiest question, honestly, because them other questions can, oh, here we go, question types. So here's one type. What is the network ID, broadcast address, first usable IP, and last usable IP on the subwork of the node, yada, yada, yada. Now that's a lot, that's a mouthful. But at the end of the day, when you read something like that, all you need to know is, hey, where's this network ID? Let me find the broadcast address and my IP addresses. Now, relevance to this question. When you are a network administrator or network engineer, you are given by your internet service provider, you're giving an IP address with a subnet, right? Something like this. They'll say, hey, here you go. You're building a network, right? You're building, you know, you're trying to get your computers connected. Here you go. What you have to do is subnet, which means you have to take this IP address and break it down into smaller IP addresses. So everyone can be on this one network. Well, you're breaking this one network down into smaller networks. So they're like sub networks of this one network. So this may be, you know, the engineering department, right? Or actually this may be the, let's just say we have Walmart. You are a network engineer for Walmart. So the internet service provider may give you, the network engineer for Walmart, this IP address and say, this is for the produce department, right? So the produce department will have devices where they scan, they have their own computers, they have trucks that are dispatching, so they have their own software, they have so much other things that are different from other departments like beauty or, you know, bed and bedding. So you would take this and you'll say, okay, well, we need to give some IP addresses to our scanners so they can scan the lettuce and the produce. We'll give some of these IP addresses to the computers for our call center agents when produce is bad or when they're dispatching truckers. We'll give some other IP addresses for the truckers to use when they are saying that they're here, you know, to dispatch their load or something. I don't know, I'm just making up stuff at this point. But just know that subnetting means that you're breaking one IP address down, one network down into multiple smaller networks. You know, why do we want to break that down? Better congestion, better traffic flow, so there's not congestion. We're not dealing with double IP, so you know you can know exactly where is data coming from and where it should belong to. Security, privacy, is so many different ways of why we want to, you know, break something from one big piece to smaller pieces. So this is a really big example, really big question you want to learn is how do I find my network ID, which is the network that I belong to, the broadcast ID, which is the address that I'm going to use to broadcast messages. And then within this IP address, I need to find which IP I can use that I can give to someone first. Well, basically it's a range. So it's the first range and the last one, right? So it's a range of things. As you can see right here, we're going to work it out, but it has the ID, the broadcast, the first and the last. So let's go in a little bit. So we have this example. This is a IP address with a what? Subnet mask, a /24. You're gonna see in the field, you're gonna see this written a lot, just like this. You're gonna have to break it down. So the first thing you do is find the octet that you'll be dealing with, AKA the class. So automatically, which octet am I dealing with? What's a /24? So I know that a /24 is what? Always you can refer back to your notes. No one's saying that you need to remember this in your head for right now. So /24 is a class C. Cool. We go back down, it's a class C. So that means that we're dealing with the first 3 octets. Okay, let's go back to our chart. Class C, the first 3 octets. 1, 2, 3. Everything else, we don't care about. Okay, so if we stay with our first 3 octets, we're only going to deal with 212.191.8. All this right here is irrelevant right now. We just want to care about this. So now that we only care about this, we take that 23. We can convert that into binary. Like I said, you should really be comfortable with breaking down decimal into binary. Okay, so now you broke that down into binary. So let's go ahead and keep this. So we automatically know, because what we're going to do, again, we are finding the network ID, broadcast ID, and the usable host range. We're starting off with the network ID. That's what we're always going to start off with, the network ID. You can't find nothing else if you don't find the network ID. We kind of just found it right there. We said it's a /24. So it's 212, keep that. 191, keep that. 8, keep that. That's all we care about. That's the start of our network ID. We don't care about this. I mean, we do care about it, but as far as like, what is our network ID? The beginning, this is what it is. But clearly, an IP address can't just have 3 numbers. We need one more number. So what do we do with this 23? That's where we convert it into binary, okay? So if you was doing this on a piece of paper, let me get my sticky out because I don't have my pen. So if you was doing this on a piece of paper, you will automatically be like, okay, well, my network ID, I know that I can, since it's a /24, I know I can automatically say that it is this. I just got to find the last octet, right? Okay, cool. So what's this last octet? Let's break it down. It breaks down this into binary, okay? So we're going to be specific with this binary and count the network bits. That means we're only counting the on bits. Which bits are on? 1. So we're only going to count 1. So if we're counting the ones, right? Like I said, there's 24 network bits in the subnet mask. 24, we only got 1. This is the 8, 2, this is 16, 3, this is the 24. I want you guys to understand that, okay? And I even broke it down here in binary so you can see it in binary form. Because again, if the binary is not clicking to you, it will not, this won't click to you. And I had to learn that and actually go back to, you know, binary, really understand it so this stuff can click. So I just, again, want to stress that. So now we have our, you know, we're not counting our zeros. Always match it up. That's why right here, I have the example of matching it up. So our /24, okay? Our subnet mask. Our subnet mask means that it is the network that we're on. We're trying to find what is our network ID. We already know we're on a /24. What is the ID of it? It is, you know, I mean, the /24 is pretty easy. We won't have too much math to do it, but we know that it's all on nothing. All on nothing. Now you can have something that's crazy like a /23. You say, oh, well, then we have to count these, you know, but as far as like simple terms, so you guys can understand, it's all on, and we just can easily see without even really doing any math that 8, 16, 24. What is this? We have nothing to count. There's no, we're not counting no zeros. Nothing to count. That's already off. If we count, we can't count this 1 because it's matched up with a 0 because we're trying to find the network ID. Network ID is so happen to be 24. It's very easy. It could be 23 to where we would have to count one of these. Actually, it could be up more than 23. It can be 25 or 26, something very odd. Then, you know, 8, 16, 24. That means we would have to count one of these, and it would be something other than 0. But since we don't, lucky for us, very easy. That's why I love these type of questions, because they're always going to give you something like, you know, very, very /8, /16, /24. So I have a 0. So what is my network ID? My network ID is 212.191.8.0. That's the last number I was looking for and the last number I got. Again, it's easy because it's a /24, but just know that it's not always going to be a 0 if it's a, you know, an oddball number. So it could be 17 as an oddball number, right? What are oddball numbers? Look at this. 8, 16, 24, 32. Those are regular. So no matter what, you're going to say, oh, this /8, that means my network ID is a 10. Everything else is a 0. If my network is a /16, what am I find my network ID? I'm going to find, it's going to be these 2 numbers, whatever these 2 decimal numbers are, everything else after that is a 0. That's easy to remember. But when you start getting into the 12s and the 17s and the 26, then it's not going to be a 0 at the end. It's going to be whatever you count the decimal form to be. And that's why I want you guys to stay in that subnetting practice, because it helps you, right? It helps you with all that math. And it's just adding and subtracting. We just did that. Now we see that the network ID bits are 0. We can assume that the network ID is exactly what that is. Okay. Now we have the network ID. You can knock that off the list. Now we need the broadcast ID. Okay. So to get to the broadcast ID, obviously we want to make sure that we always have our bit chart up and our place values. We know that our place values all equals 255. So if our network ID is, again, this is easier because it's all 24. We're taking this. Our network ID, we're taking this at the end of it, which is our broadcast, and we're just going to turn them on. We're going to add them. Now we're going to count the zeros. Count the zeros, they're all add up to 255. Now, if there was a 26, right, we would have probably one of these on. 24, 25, 26. We'll have this one on because it's number 2. We'll have the middle bit on. So therefore, for the broadcast ID, we'll only be able to count the ones that are not on. Now, you really have to do this with like practical practice. That's why the subnetting is very easy. That subnetting practice little thing I sent y'all, because it's kind of like difficult to explain unless you are actively like working out the problem. So how to subnet, learn how to subnet, oh, hold on, calculators. There we go, basic subnetting practice. So for 24, you know, you can show answers. You see how it even has a 29? You know, 24s are easy, 16s are easy. Oh, here's a 24. Oh, not submit, show answers. Oh, actually, this don't even tell you about the usable host. Let me go here. Subnetting practice. Let's do this one. There we go. This one is where I want you to go. Am I recording this? Yes, I am. Because I'm gonna do all of that. But anyway, so yes, I would say go here. Questions, subnetting practice. Don't do the basic subnetting because it's gonna convolute all what we talked about. So do just this subnetting practice, question subnetting practice, and come here and practice on these. So when they asking you about find the broadcast ID, find the network ID, you're working on the slashes, which is easy for us to know. It's not human language. Computer language. Computer language is a 255. We just use it in a /24 because it's easier on us. We lazy, we're humans. So just know that when you see a slash, that means that, you know, it's easier for us to read. But in form, this is what it is, you know. So we're gonna say, what is it? We're gonna keep going, right? Show answers. Even with this, it's gonna tell you the broadcast ID, show answers. Tell you the last valid host. Now you can skip these because we ain't there yet. We ain't there yet. These are questions we're gonna get into. But we got to get down to subnetting first. Okay, where we at? Okay, cool. So the broadcast ID. So we have the net. So you guys understand how to get the network ID. You get the network ID by looking at the subnet mask, whatever the slash number is, and you count that. Whatever the number is, let's say it's 26, you count 26 ones. Wherever it lands, that's where the network ID is. So if I count 24 ones, guess what? This is the network ID, whatever's above 24 ones, which is this right here. We don't have to do much math because this is 24 ones. This right here, right? 24 ones, if we break it down into octets, what is that? 8, 16, 24, that's 3 sections, okay? That's the network ID. Everything else null and void. Count that as a 0 because we're only doing 24. Let's say if it was 26, we'll have 8, 16, 24. We'll have to do a 21, 24, 25, 26. That means that down here, we will have to count all of this. So what would be our network ID? We would have to count 128 plus, what is that, 64? And that'll be that. But we ain't there yet, so don't get crazy. Just practice this practice this right here. You know, skip the questions that we didn't talk about, obviously, but practice these. So you can, once you get the whole question, you got to do the broadcast and the network and the host usable range. You know how to do that because you've been working in binary so much. Okay, so we got the network. Now we got the broadcast because the only way we can find the broadcast is if we find the network. The broadcast is everything else left over. So you cannot do it out of order. You have to find network and then you can find broadcast. Broadcast is 255. That's pretty simple and because it's all 0. Okay. If it wasn't 0, let's say it was the 26, we can only count these 6 bits, which would be whatever that equals up to, whatever 1, 2, 4, 8, 16, 34, 32 all equal. That's where my calculator would come in, or that's where I would use the paper and literally add 1, 2, 4, you know, because that's just how I do my math and I don't care. All right, so boom, you would do that. That's your network. Now you find your broadcast. Now you have your network and you broadcast. We have the network, we have the broadcast. So now we can find the usable IP addresses that we can assign to our call center agents. So our first usable and our last usable, this is the only rule I can tell you that it just helps me. You can do all the math you want, but this is the rule. When we want to find the first usable, we use the +1 for the network ID. So this is the network ID. They say, what's the first usable network out of this network ID? Just +1 to it. So what does that mean? It stands for a 0. If I +1, it's a 2. It's a 1. If this was our network ID, I would +1 and it would be a 2 right here. So just +1 at the last octet. That means that that IP address is free to use, so you can assign it to a call center agent or to some device on the network. The network ID, you cannot assign that. That is the network. No device should be using the network ID. They need to use their own IDs. And you're going to +1. Now for the last usable, you're going to take the broadcast ID and subtract a 1. So if it's 255, if we subtract the 1 from 255, what does that equal? 254. So you are able to use this IP address between this IP address as the first one and this IP address as the last one, which can come up to like 253 IP addresses. So you have 253 IP addresses that you can use, and you can assign them out to everyone on this network. Now, in the field, like I said, your internet service provider will probably break this all down for you. If they don't, the network architect will break all this down for you. The architect may even say, hey, I want the administrator to do this, the network administrator to do it, probably on some passing the ball, passing the buck, which is good because as an administrator, you get this knowledge, even though this is architectural knowledge. And this is good because if you work for an internet service provider, you know exactly what to do. Now, another thing in the field is they do all of this with a calculator. There's literally a subnet calculator. So where we use in the field to get us what we want. We choose our class, we choose our subnet. So if the internet service provider tells us what we want, we just calculate it and it tells us which we can use, what's our first usable, what's our broadcast. So we don't even have to do all this math, some real. But unfortunately, for the exam, you do need to know it. To be able to talk that talk, you should know it, right? If you're over here demanding $100 an hour, you should at least be able to find the network ID and the broadcast ID and the IPs that we can use on our network. If you want to get paid $100 an hour, 8 hours a week, 40 hours a week, that's well over 100,000 a year. It's probably like $250,000 a year. So learn it so you can get $250,000 a year. Or you can just be lazy and use a subnet calendar and get paid $75 an hour. Both is still good, but one just reigns supreme. So I would suggest you learn it so you can at least pass the exam, at least get some of these questions right. Learn it so you can have the notoriety to say, hey, I'm rich. But don't beat yourself over it. If it's not clicking to you, move on. We'll get back to it. It ain't no fret. Don't get crazy. Oh, here's a link right here. See, I even had a link in here, so you can definitely use this link if you don't know where else. But there are other questions. Go through these questions on your own time, because honestly, it's not vital to your success as to increase your income through tech. But it is, again, very helpful to get even more money, right? Because we all can come out of this class making different amounts. We can start off at 0, take this class together, and then at the end of the 6 weeks, all have different pays, because it depends on how much information we all retained. So if you're the type to, can retain all of this, and you getting all these 3 questions and you a boss, because look at this one. Question 2, how many subnets and hosts per subnet can you get from the network? And it tells you this network. That's good and all. Honestly, I can't do this. I can sit here and follow these steps, practice these steps, and then get another question and get that question right. But I gotta practice these steps. And we honestly use calculators in the field. And I mean, it's cool. I'm not trying to be the best network engineer out here. I'm just trying to get more money. So I like to do the first question. As long as I can get this down packed, then I know what I'm talking about, and I could be an architect, which I have architect. That's been one of my positions in one of my contracts. So something that you're definitely going to need to know, but it's not vital for your success. Let me put it that way. Okay. So that is subnetting, you guys. It is the most math you will ever do as a network engineer. I don't know about any other things you want to choose in tech, but as a network engineer, this is the most math you're going to do. And I broke it down to adding and subtracting. As you can see, you can do it in like exponents. Let me see, you can, start multiplying and dividing. That's just not my strong suit, y'all. That's just not my strong suit. So, oh, and here's something else, you can definitely have more resources in this PDF, right? Look at the first octet value. The first octet value should be this that matches up with this class. And here's an example, right? This is vital for your success. If you don't know this stuff, then you're definitely not even finna get like $40 an hour. You need to at least know this, right? And then configure and verify. Tomorrow, we will configure IP addressing. We actually did a little bit yesterday. Let's just do it now. So when you're in your packet tracer, you should already have a network built because that was your lab for yesterday. So if you don't, build a little simple network of some devices. But you come in to your end device and you literally just add on. Let me do that slowly for you guys. So you come in here, IP configuration. That's pretty simple, right? Go to IP configuration. And you literally set up an IP address. You can choose any IP address your little heart desires, because this is a network that we are building. This is our network. We choose what we want to choose. You want it to be private, you want it to be public, you can do it. Obviously, this is simulation, so it's not like real deal on the internet. You really can't send data to your Cisco packet tracer, but you can play around with, the IP addresses. So add an IP address. I always go to 192. That's like a default for everything. So 192.12.1 automatically is going to give me a subnet mask. You already know what subnet mask is going to give me by default because I started with 192. So I'm going to press enter. And look, it gave me the subnet mask automatically, which is a /24 because it's a class C and 255.255.255/24. Default gateway, we ain't there yet, so I'm not even going to get into it. And then again, this is statically configuring. We can even do DHCP, which is automatic configuring. But you see how easy that was? That's what you do. As a network administrator, you say, hey, give this device an IP address. Most of the time, I'm going to do this. Do I want to show y'all? I can't do it on the switch because switches don't have IP addresses. And I'm not going to show you on the router. We're not there yet. I don't want to confuse you guys. All you need to know is where to put this IP address on the desktop. Okay. Exactly how you would do it in real life. You would go into the computer and change the IP address. I can do that here, but I don't want to change it because then we're going to get cut off because, that's my IP address. And then here's some questions that I added for you guys. Oh, configure. Oh, I put this on here, configure on the router. So how about that? How about for homework? I want you guys to figure out how to configure an IPv4 address on a router. We're going to do that tomorrow, but why not go ahead and jump the gun and see if you can do it now? Okay. And then that's really all I have for you guys. Okay, so I come in here, I'm going to add this stuff in here. Let's add, what is a network? Where we at? So do you guys have any questions, comments, concern? Let's have a little talk.
Nah, that was cool. Like I said, my instructor, he tried to teach me the like the old school way that nobody uses anymore, and that's confusing with technology when you upgrading every month, every day for real. So seeing how you just broke that down, subnetting, I was like, man, if he did that back then, I'd have been, you know what I'm saying? I'd have knew this. But hey, it's more knowledge that I'm obtaining, so I ain't complaining.
Yes, yes. And what I've learned, just teaching myself and going through the program Ashton, and I've been on 4 contracts so far. And what I've learned is, the way that they teach, whether, it's on YouTube or in the field or whatever, the way they teach is not really for us, it's really for, them. If you know, you know.
Facts.
So yeah, so it's kind of like hard when it's like we don't speak the same language, and sometimes you do have to break it down to our language, how we understand things. And some people may say you're dumbing down the language. It doesn't matter. However, how you need to explain it, you should explain it. And if you cannot explain something to like a 5th grader, then you don't know the information yourself. So how I look at it as, you guys, not you guys, but people on the field, teachers, they should be explaining this type of technology like they're talking to middle schoolers or 5th graders, and that's feel like that's how everyone will be able to be like, oh, the aha moment, so we can actually be out here and get this money. Because when you're talking to us at this high level, it is kind of intimidating. And it's like, what the hell? And it's like, we don't even have to, it don't have to be that hard, right? So whatever. So yeah. Okay, so that's that. That the OSI model. Actually, let's put the OSI model up here. And then I don't know if I have this saved. Not a page. Come on now. So yeah, no more questions. Y'all got nothing to talk about. Are y'all getting it? Am I going too fast? Let me know.
I mean, you did say we're cramming a 2-year? Is it a 2-year or a 4-year degree into 6 weeks?
4 years.
Yeah, it's fast, but it's what we signed up for. We're here. So this is a really interesting subject, the subnetting and IPv4 addresses. Are there specific jobs or careers specifically tailored around handling this all day? Like assigning IP addresses, or like, how's that work?
No, it's kind of like part of your job as a network architect. So if you were to assign IP addresses, your job title would most likely involved in architecting, engineering, possibly, right? Possibly, maybe a senior engineer, you would be doing this. Or if you worked for an internet service provider as a network engineer, you would be using this tool, this skill. However, in the field, because my last contract for Performance Food Group was actually a senior role, and they gave me my IP addresses already. I didn't have to subnet, and that was from the internet service provider. So it all depends on what company you're with, or with what vendor you have, what internet service provider you have. Are they going to, and then with the employee, you got to remember too, all of these are just jobs. So if someone's saying that, well, my job is not necessarily to subnet this for you, I'm just going to give you the whole IP address and you can do it yourself, then that's just the representative that you work with at that company, unfortunately, and you have to subnet. Now, again, there's not really a job depending on that, because I mean, we can literally we have a calculator that can just do it. Yeah, and most of the time, yeah, here we go, the IP calculator. We can just do this. And most of the time, there's someone that's building something that does this automatically. So that job used to be, plentiful, but computers do it now. So you got to come with more skills.
Got it.
Yeah. Okay, and then let me see what else I need to put here. And like I said, subnetting is a lot to intake. However, if you don't have at least the foundational, which is like binary conversions, binary decimals, then everything else won't make sense. But if you at least have the binary decimal conversion, then everything else is like, oh, okay, you can kind of get it from a high level. And that's really all that matters, is that you can understand this from a high level, because every network is different. So just because you've learned how to do this way, don't mean that it's the same way at Walmart as a network engineer or at Vanguard as a network engineer. You know, PNC, I worked as a network engineer for PNC, and they're completely different from, you know, Performance Food Group or even from the hospital. Even though, you know, they kind of use the same systems, which is Cisco, it's still very different. Very different. So, yeah. So what is a network? So it's all about having a foundational knowledge, and it's also about knowing things high level. You can play around and talk. Okay, cool. So we talked about that. Now for lab, what did I say for lab? Oh, I said you can, if you want, configure a router with an IP address, but you just want to really do that computer, which was easy. Print. I should probably put that into like a PDF or something, so you guys can actually have it as visual. But as long as you're working through like these sessions, whether they're recorded or not, you kind of know what's going on. And then flashcards, obviously, click here for the flashcards, maybe. And it's for studying your quizzes and all that stuff. It's to help you retain. Now, again, I'm not going to teach you every single little thing. It wouldn't work. It wouldn't work in 6 weeks. Well, it wouldn't work in like these couple of hours a day. We would have to be studying for like 4 or 5 hours a day to teach you every little thing on the CCNA. So that's why I gave you the book. That's why I give you these texts, these PDFs, my blogs. I give you these labs, and I give you this right here. All of this encompass the CCNA. But you sitting here just listening to me talk, take notes, it's like 70% of information. Okay, so go to network fundamentals, and we're gonna do the same thing we did yesterday, right? We had the flashcards. You already know what a three-way handshake is. TCP, sense and act, right? DSN port number. Remember I told you need to know some port numbers. 53, UDP and TCP, they use both. So you see, oh, let's see what this one is. List the 3 private address blocks. You should automatically be like A, B, and C, 10, 172 dot something something. You may forget that, but at least you know it's 172 and then 192.168. You should automatically have that off the rip in your brain. Everything else you may have to, you know, use these flashcards to make sure you know this one. This class B was always the one that got me, because I'm just like 172 dot what? Now I can remember anything with a 10, and I can remember anything with 192.168. But this /12, yeah, you got to know it's 16 to 31. It always gets me. But again, it's multiple choice, so it's really all about memory. Can you have a photogenic memory? But yeah, so I got all of this. Y'all learn it, okay? Remember, we got the test, we got gravity, you know, true or false. Is this the DNS port number, right? We got the matching game. Matching game is my favorite, even though I suck at it as far as time. Gravity, I started using gravity not too long ago. It's actually fun. We want to study all of it. Let's make it easy. Sometimes we gotta easy on yourself. And what is this? Type your answer. What's going on? What is the 3-way handshake? I'm gonna say TCP. I don't know, TCP freaking. Oh, I already gotta put send act. See, I don't even know how to play my own game. Oh, they want me to write the whole thing out. See, that's not gonna work. So maybe gravity won't work for this slack of cards, because you literally have to write out the whole thing. So no gravity for this section. Maybe the last section you can do it. Spelling, writing. I don't care about you spelling or writing. But flashcards is really what you want to do, and matching is really what you want to do. because matching is like, you know, you're just matching definitions. Okay. So be like, what's a multicast address used to send a group a message? What's the binary range in decimal form? I'm gonna say is this network layer 3. I don't know how many bits in the source. Boom. What's this DNS port number? Provides logical addressing. Network layer 3, and obviously this is just by default. So 29 seconds. Boom. Let's see if you can beat mine. So yeah, it's pretty fun. I'm not gonna do that again. But pretty cool. Help you learn, help you retain. Please use it. You know, it helped me. I'm really just giving y'all what helped me. So, you know, there should be no reason why, if you actually follow everything that I give you, all of my resources, and come to class every day, there should be no reason why you don't pass on the first go. It's not hard. It's hard to learn to retain this information, but the exam is like, it's easy because it's multiple choice, you know, but whatever. That's it. That's really it, y'all. Let me stop sharing. Thank you for coming out. I appreciate y'all, you know, making it once again, day 2. We got day 2 of week 1. We got a lot. We got 6 weeks, but no fret. All right, y'all. So yeah.
Thank you.
You're welcome. Any questions, just reach out to me in Discord. I'm here for y'all success. So have a good night. Talk to y'all tomorrow.
You too. Peace.
All right. Bye, guys.